Good morning, friends. I, Dr. V. M. Tidke, Sanjeevani College of Engineering, welcomes you all. Today, under Decision Science, let us continue our studies of linear programming problem. So, try to do formulation of LPP model practically. So, at the end of the session, every student will be able to formulate LPP model. Let us see the practical situation. Friends, there are two products, chairs and tables. And there is one company who has to make the decision regarding how many of each of these chairs or tables that needs to be manufactured with a view to maximize the profit. So सिचुएशन समझ में आ रहा है? एक कंपनी है जिसको चेयर्स और टेबल्स बनाने हैं और उनको वो इस कॉम्बिनेशन में बनाने हैं ताकि कंपनी का प्रॉफिट जो है वो मैक्सिमम हो. तो दिस इज द सिचुएशन. Based on that, they have given you certain information. The information is put in form of table. You can see that one table is giving a profit of rupees 7. Whereas if you sell one chair, you are getting a profit of rupees 5. Secondly, they have also provided you the data regarding the number of hours of carpentry and painting required to manufacture a table and chair. So in case of carpentry for tables, it requires 3 hours to make one table needing the carpentry hours, and for making one chair you requires 4 hours carpentry work. Whereas the total number of hours available for carpentry are 2400 hours only. Secondly, for manufacturing one table you requires 2 hours of painting, and for chairs you requires 1 hour of painting, whereas the total number of hours available for painting are 1000 hours. Above are the informations, and there are few more limitations. Number one, you cannot make more than 450 chairs, and you have to manufacture at least 100 number of tables. So this is the data given to you. ओके, तो अब सिचुएशन समझ में आ रहा है. एक कंपनी है जिनको की टेबल और कुर्सियां बनानी है, और वो बनाते वक्त उन्हें ये सोचना है कि ऐसा कौन सा कॉम्बिनेशन होगा जिसके तहत उनका प्रॉफिट मैक्सिमम होगा. एंड व्हाट इज द इंफॉर्मेशन? अगर वो कंपनी एक टेबल को बेचती है तो 7 रुपया प्रॉफिट होगा, एक चेयर को बेचती है तो 5 रुपया प्रॉफिट होगा, और एक टेबल बनाने के लिए 3 घंटे का कारपेंटरी का वर्क लगता है और 2 घंटे का पेंटिंग का वर्क लगता है. सेकेंडली, एक चेयर बनाने के लिए 4 घंटे का कारपेंटरी का वर्क लगता है और 1 घंटे का पेंटिंग का वर्क लगता है. एट द सेम टाइम आपके पास सिर्फ 2400 घंटे है जिसके लिए आप कारपेंटरी कर सकते हो, और सिर्फ 1000 ही घंटे हैं जिसके लिए आप पेंटिंग कर सकते हो. ओके, ये छोड़ के कुछ और लिमिटेशंस है. आप 450 से ज्यादा कुर्सियां नहीं बना सकते हो, और आप 100 से कम टेबल्स नहीं बना सकते हो. So this is the information which is roughly given to you, and as a businessman or as a decision maker, you have to develop a model which can give answer to this question. So let us move further. Now we note, we have to identify the number of units of table to be manufactured and number of units of chairs to be manufactured with a view to maximize our profit. So our decision variables are X, which is number of units of tables to be manufactured, and Y, that is number of chairs to be manufactured. Secondly, on the basis of this on the basis of this decision variables, we can develop our objective function. आपको तो पता ही है हमारा ऑब्जेक्टिव फंक्शन है टू मैक्सिमाइज द प्रॉफिट. अब प्रॉफिट कैसे मैक्सिमाइज होगा हमें तो पता है. अगर हम एक टेबल बेचते हैं तो 7 रुपये का प्रॉफिट आता है. इसका मतलब अगर हम x नंबर ऑफ टेबल बेचेंगे तो हमारा टोटल प्रॉफिट आएगा टेबल के सेलिंग से 7x. सेकेंडली, अगर हम एक कुर्सी बेचते हैं तो हमारा प्रॉफिट होता है 5 रुपया. अगर हम y नंबर ऑफ चेयर बेचेंगे तो हमारा प्रॉफिट होगा 5y. सो कंपनी का टोटल प्रॉफिट क्या होगा 7x plus 5y. So our objective function is nothing but to maximize z, which is 7x plus 5y. पर ये करने के लिए हमारे कुछ लिमिटेशंस भी तो है, उन लिमिटेशंस के भी हम इक्वेशन बनाते हैं इन द फॉर्म ऑफ कंस्ट्रेंट इक्वेशंस. नंबर 1, आपको याद है कि आप 2400 से ज्यादा घंटे तक कारपेंटरी का काम नहीं कर सकते हो. And at the same time, you knows to manufacture one table you require 3 hours of carpentry. So to manufacture x number of tables you will be needing 3x number of hours of carpentry. Secondly, एक कुर्सी बनाने के लिए 4 घंटे का कारपेंट्री का वर्क लगता है और आप टोटल नंबर ऑफ कुर्सियां y बना रहे हो. So the total number of hours of carpentry for manufacturing chairs would be 4y. So the total hours of carpentry in this case would be 3x plus 4y. But at the same time आपको ये भी तो बताया गया है कि आपके पास सिर्फ 2400 घंटे है कारपेंट्री का काम करने के लिए. तो इसका मतलब आपका ये जो 3x plus 4y माने टोटल नंबर ऑफ कारपेंट्री यूसेज इन आवर्स 2400 घंटों से ज्यादा नहीं हो सकता है. कम होगा तो चलेगा. सो द सेम थिंग वी कैन पुट इन टर्म्स ऑफ इक्वेशन. हियर इट इज रिटन 3x plus 4y less than or equal to 2400 hours. Getting my idea? Secondly, आपको पेंटिंग के लिए सिर्फ 1000 घंटे दिए गए हैं and for doing one table you requires 2 hours of painting. So for doing x hours of table manufacturing you requires 2x number of total hours of painting. And for manufacturing one chair you requires 1 hour of painting. So for manufacturing y number of chairs you will be needing 1y number of hours of painting. So the total hours of painting required would be 2x plus 1y. पर ये 1000 घंटे से ज्यादा नहीं हो सकता है. So the equation goes 2x plus 1y less than or equal to 1000. Moving further, आपको एक और इंफॉर्मेशन दिया गया है कि आप 100 से कम टेबल नहीं बना सकते हो. So x has to be greater than or equal to 1000, where x is nothing but the total number of tables to be manufactured. Secondly, आप 450 से ज्यादा कुर्सियां नहीं बना सकते हो. So your y has to be compulsorily less than or equal to 450, which is your another constraint equation. Secondly, non-negativity condition. दोस्तों, आप निगेटिव नंबर ऑफ चेयर्स और कुर्सियां नहीं बना सकते हो. So x has to compulsorily be more than 1. So x is greater than or equal to 0 and y is greater than or equal to 0. तो ये सारी चीजें अगर हम इक्वली लिखते हैं तो उससे बनता है हमारा LPP मॉडल. तो यहाँ पे आप देख सकते हैं, here the LPP model says maximize the objective function z, which is 7x plus 5y, which is subject to the constraint number 1 3x plus 4y, which is less than or equal to 2400, which is nothing but a carpentry work hour limitation. Secondly, 2x plus 1y, that has to be less than or equal to 1000 hours, which is nothing but a painting hour restriction. Thirdly, x has to be greater than or equal to 100, that is your number of table has to be more than 100. Secondly, your y has to be less than or equal to 450, that is you cannot manufacture more than 450 number of chairs. And lastly, non-negativity condition of x and y has to be compulsorily more than 0. So in totality, this is how your LPP model gets formulated. I hope you have understood the video, and on the basis of this you can see that a general formulation of LPP is simply either to maximize or minimize the Z, which is a C1 plus C1x1 plus C2x2 plus Cnxn, which is subject to certain limitations like A11x1 plus A12x2 plus A1nxn, which can be either of less than or equal to type or equal to type or greater than or equal to type to B1. And secondly, A21x1 plus A22x2 plus A2nxn less than or equal to or greater than or equal to B2. Moving it to the last one, and on the basis of the non-negativity conditions like x1 is greater than or equal to 0, x2 is greater than or equal to 0, so on and so forth, where xj is a decision variable, bi is a constraint levels, Cj is the objective function coefficients and Aij are nothing but the constraint coefficients or the constants. I hope you have understood the video. Now let us do a small exercise. Download any 5 examples of LPP model which will further strengthen your understandings of how LPP models are getting formulated. Thanks for watching the video. I hope you have learned the video. For any questions, you can contact me on below mentioned details. Thank you. Have a nice time.